Here we're going to look at what is an extra activity. I'm calling it an extension activity. It means you don't actually have to do it for our course. We will encounter this later on in the advanced valuation course, and so it might be worth your while to do it as an extension activity here. What we're looking at here is the question of where the annual rates, like the rent or whatever, is increasing year by year. This is a very practical question because while financial textbooks tend to have examples such as what I've shown you previously, the $100 per year for 10 years, that sort of stuff, a lot of you know that in the real world rents go up year by year by year, and so those financial calculations do not appear to apply. However, we can get them to apply by simply changing the discount rate to incorporate growth. And so here I'm going to show you how to work out what I'm calling a compounded discount rate, which is where you roll the growth rate and the discount rate, one effectively going up, one effectively coming down, together to give you what's called a compounded discount rate. And then we use that for the same calculations, and we find that we then have accommodated the fact of growth. Let's look at the basic calculation. The algebra, if you like, is shown in this box here, and all we're going to do in this slide is merely apply it. We're going to put it into this cell. And so the Excel equation looks a little bit awkward, but it's worth doing it yourself. It's 1 plus the discount rate, close brackets, divided by open brackets, 1 plus the growth rate, close brackets, and from all of that you subtract 1. And so it means that if you've got a discount rate of 13%, however you've got a growth environment of 3%, you've actually got an effective discount rate, a compounded discount rate of 9.71%. It's almost 10%, so a lot of people just do a little bit of mental arithmetic and say that the discount rate is really about 10%, but it turns out that the most precise way is to use that equation. So it's not quite 10%, not quite the simple arithmetic difference. You use that more complicated thing, and it's worth your while learning that. We're going to apply that now in a practical situation. We're going to look at a situation where I've got rent of $100,000 per annum coming in. I might have an industrial unit or an office space or something which is earning me $100,000 per year, and that's anticipated to grow at 2.5% per annum, which is fairly typical of many markets over the last generation or so. The investor who's thinking about buying this investment property would like to get a 14% return on their money, so that's the discount rate, 14%, and we're considering it over 10 years. First thing we're going to do is work out the compounded discount rate. Now you'll find that's simply doing what was on the last exercise, and so it's applying this equation which I've written here in red to give you a little tiny bit of a hint. I'm actually not going to do this equation. I'm going to get you to do it yourselves because I think you're capable of it, and this is an extension activity. This is an activity for those of you who want to do a bit of extra work, want to get a little bit deeper into it, maybe see themselves as having an interest in mathematics and this advanced approach to property analysis. And so I don't really want to hand feed you all the way through. You might find it frustrating. You came to university, not to TAFE. So I'm going to leave that to you to work out that equation. That's not hard, is it? The next thing is to look at the term value of the lease to the owner. Now, the term value is something we're going to again come into in advanced valuation. So again, this is only for students that are interested in going a little bit further at this point. You'll find there's a bit of a hint here which tells you exactly what function to use, how to use it. So you should be able to get rid of that yellow highlight by writing a relatively simple PV function. In addition to that, this exercise gives you the scope, the opportunity to work out or to check the calculations using the old longhand approach. Here I'm going to ask you to write out the rents as they grow year by year, and then to discount them back year by year, much the same as what happened on the financial functions diagram. And hopefully when you sum them down here, you should end up with the same number as we got up in cell E15. And that gives you a nice satisfying check, as well as getting rid of the yellow highlights. And again, for those of you who are interested in really understanding this very, very thoroughly, that should be a very satisfying little experience, which I will leave you now to do yourselves.